A new AI understands both human language and atomic structures, letting it invent materials. This could fundamentally change scientific discovery. Let's get into it. Let's start with today's featured paper, Atomistic Language Models Understand and Generate Materials, by Satya Edemedaka and Rafael Gomez-Bombarelli from Massachusetts Institute of Technology. By proposing a single model that natively understands both natural language and the geometric structure of atoms, this paper represents a significant leap towards true multimodal AI for scientific discovery. Here's a full breakdown.
Here in Panel A, we see the core architecture, which brings together three key parts. An atomistic foundation model first understands the input crystal, which is then processed alongside a text prompt by a large language model to guide the final generation. Feeding into the final stage, the system uses a continuous bridge to translate the language model's understanding directly into instructions for the generation process. This allows the text prompt to precisely steer the atom decoder in creating a new material. Next, to generate a chemically valid structure, the model employs a specialized particle sampler within the atom decoder. This component carefully guides the atom placement to ensure the final crystal has the correct stoichiometry, as mentioned in the text response. The ALM-edit method substantially outperforms prior work on the MP20 and MPTS-52 benchmarks, achieving significantly lower RMSE values and higher MR at 20 scores. While the ALM-Gen plus T2CFK method achieves the lowest RMSE at 20 across both benchmarks, its MR at 1 and MR at 20 scores are considerably lower than other models.
Up next, our second paper out of 10, A-Evolve Training, Autonomous Post-Training of a 30B Model by Zhan Shi and Hanqing Liu from AEVO Lab, Amazon. This paper presents a groundbreaking proof of concept for automating the complex, human-driven process of post-training, achieving near-human expert performance on a competitive reasoning benchmark. Let's break down its key contributions.
At the core of our work is an autonomous system that automates the entire post-training process, cycling through discovery, coordination, and experimentation. This process begins in an immutable system, which is copied into isolated candidate sandboxes, where parallel workers can run experiments without interference. Feeding into this loop, a reviewer agent synthesizes the results from all parallel experiments. This evidence is then passed to the orchestrator agent, which updates the rolling search policy under a set of constitutional constraints to guide the next round of experiments. Next, after many cycles of this autonomous process, the system converges on an optimal configuration. The final artifact of this entire scale procedure is the best evolved recipe and a resulting improved reasoning model. The autonomous loop method shows a consistent improvement in its leaderboard score over 4 rounds, starting at 0.80 and reaching 0.86. However, this performance remains slightly below the human number 1 baseline, which achieves a score of 0.87.
Up next, our third paper out of 10, Discriminatory Compliance, How LLMs Answer Queries from Protected Groups by Dinesh Ayyappan from Universitat Pompeu Fabra. This work identifies and names a subtle but critical failure mode in AI safety, providing a new conceptual framework that will directly influence the design and auditing of responsible LLMs. Let's break down its key contributions.
To start, let's look at how we set up our queries to test for bias. The disclosure column on the left shows the different categories we used, ranging from no disclosure at all to explicit or implicit statements about a user's condition. Feeding into this, the phrasing preceding the query column shows the exact text used for each disclosure type. This allowed us to see if the model's response changes based on whether a user says, "I have depression," versus simply describing their symptoms. Next, we discovered that these inconsistent responses often result in the model withholding crucial information from users who disclose a protected status. This means the quality and completeness of the answer can be detrimentally affected by how the user introduces themselves. Finally, this discriminatory behavior varies significantly depending on the specific context. We tested this by creating distinct scenarios, such as the depression condition versus the subclinical, low mood condition shown here, revealing how sensitive the models are to these changes. Opus 4.6 generally outperforms Qwen 3 and GPT-Safe in providing professional referrals for both Type 1 protected groups and Type 2 disability categories. However, Opus 4.6 performs substantially worse than Qwen 3 and GPT-Safe when providing crisis resources for these same groups, often showing very low compliance.
Up next, our fourth paper out of 10, Self-Improvement Can Self-Regress, The Rise and Collapse Failure Mode of LLM Self-Training by Jianjia Lin from Meadow AI. This paper identifies, names, and carefully characterizes a critical and previously undocumented failure mode in LLM self-improvement, providing a crucial scientific insight into the stability of modern training techniques. Let's break down its key contributions.
First, let's look at the CARE mechanism, which is the overall architecture for managing self-improvement. Its core decision-making component is Module 2, the Self-Improvement Transfer Gate, which intelligently decides whether to reuse, adapt, or even reject a new strategy. This is complemented by an early stop rule that operates within each training campaign. This rule dynamically adjusts the training budget and rolls forward the best checkpoint to prevent performance from collapsing. Finally, to make the policy optimization itself more stable, the system uses a novel update method called GRPO. It leverages group relative reward normalization to guide the model effectively and robustly during self-training. The deployed ES method achieves the highest performance in the achieved percent metric, reaching 22.2%. This result is notably higher than all other listed methods, and it also shows strong performance in the hindsight percent metric.
Up next, our fifth paper out of 10, Safe to Check, Unsafe to Use, Relinking at the Compression Boundary of LLM Agents by Zixin Liu and Dongdong Shi from the Hong Kong University of Science and Technology. This work identifies relinking, a novel and subtle compression boundary security vulnerability, where an agent summarizer can be tricked into assembling a malicious instruction from distributed, benign text fragments. Let's break down its key contributions.
Here in the top left, we start with our inputs, including a malicious payload instruction represented as a payload instruction graph. This graph shows the core components of the instruction, like an ACT and a value linked by a binding edge. Feeding into our method, we see how this attack is constructed in 3 stages, beginning with Stage 1, Decompose. This structured process shows how we can systematically break down the malicious payload into its constituent parts. Next, our automated tool implements Stage 2, Disguise, where the decomposed components are further obscured. Each component, like ACT and value, is associated with a generic CUE to make it appear more benign and less suspicious. Ultimately, this process generates the final adversarial context, which is what a defense mechanism must analyze. Although our proposed KBRA defense isn't depicted, it is designed to process this very context to prevent the malicious instructions from being reassembled and executed. The KBRA methods demonstrate excellent attack blocking, achieving bar after scores as low as 0% and attack block rates up to 100%, which is on par with or superior to most other defenses listed. Notably, KBRA semantic backend stands out with a very low 0.93% utility FP, making it highly effective while maintaining reasonable computational costs compared to many GPU-based alternatives.
Up next, our sixth paper out of 10, The Substrate Collapse, AI Code Generation Invalidates Authorship-Based Knowledge Metrics by Brett Wheeler from Independent Researcher. This paper makes a profound and timely argument that a foundational assumption in software engineering has been broken by AI, forcing a necessary reevaluation of how we measure knowledge and risk in code bases. Let's break down its key contributions.
Contribution 1. The authors argue that AI code generation fundamentally breaks the traditional inference that code authorship implies understanding. This invalidates existing authorship-based knowledge metrics. Contribution 2. The paper highlights how AI-generated code causes authorship metrics to measure a substrate uncoupled from the actual knowledge quantity. This reveals a critical measurement failure. Contribution 3. The system proposes that future knowledge metrics must be grounded in direct evidence of comprehension, moving beyond mere authorship attribution. This redefines the measurement paradigm. Contribution 4. The authors introduce a falsifiable prediction, distinguishing between authorship-derived and comprehension-measured systems. This provides a testable hypothesis for future research.
Up next, our seventh paper out of 10, The Table Says Otherwise, Testing LLMs with Counterfactual Relational Data by Xinji Wang and Chunwei Liu from Purdue University. This paper introduces an elegantly designed and critically necessary benchmark that uses counterfactual data to rigorously test whether LLMs are truly reasoning over provided structured data or merely recalling pre-trained knowledge. Let's break down its key contributions.
First, let's look at how the benchmark is structured. breaking down questions into different levels of difficulty. We have everything from simple single-table lookups to more complex multi-table reasoning, each with a clear definition and example. Feeding into this, the core idea is to test the model against both a real-world database and a modified, counterfactual one. The questions, like the example shown here, are run against both versions to see if the model is truly reading the table or just reciting memorized facts. Next, the questions themselves are designed with 3 distinct levels of complexity, as laid out in the level column. These range from a single-table lookup all the way to multi-table temporal reasoning, ensuring a thorough test of the model's abilities. The evaluation method reveals that top LLMs like Gemini 3.1, Flash, Lite, and GPT 5.4 many achieve high overall scores on original data, exceeding 90%. However, these models and others show a noticeable performance degradation when confronted with counterfactual data, particularly as the complexity level increases.
Up next, our 8th paper out of 10, Deep RL for Fast Long Horizon Operations Scheduling on NASA's Carruthers Geocorona Observatory Mission by ArXiv June and Laura Waldrop from University of Illinois Urbana-Champaign. The successful deployment of a deep reinforcement learning system for a complex, real-world NASA scheduling problem represents a landmark achievement for applied AI. Let's break down its key contributions.
Let's start by looking at the overall Deep RL framework, shown here in the training block. This system uses multiple parallel environments to generate data for an agent, which is then updated using a PPO update mechanism. Feeding into this process is a key abstraction, which simplifies the problem by grouping low-level commands. Inputs from the mission and science ops teams are processed by the activity block generator to create these high-level activity blocks. Next, to ensure all schedules are valid, the framework uses a special constraint handling technique. The environment's mask generation step produces a mask that the agent applies during masking to prune invalid choices before action sampling. Finally, the resulting optimal policy is used to generate a schedule, which then enters the verification and validation pipeline. After passing a constraint checker and a final human check, the approved command sequence is ready for upload to spacecraft. The DRL method achieves the lowest cost of 256.98, outperforming the baseline and other A-optimality and D-optimality heuristics. It also schedules the highest number of activity blocks and images, despite a lower percentage of time spent on stars.
Up next, our 9th paper out of 10, GroundEval, a deterministic replacement for LLM-as-Judge in Stateful Agent Evaluation by Jeffrey Flint from Independent Researcher. GroundEval offers a powerful and deterministic alternative to the flawed LLM-as-Judge paradigm, enabling rigorous, evidence-based evaluation of agent behavior by verifying the agent's information-seeking actions directly from its trace. Let's break down its key contributions.
Let's start with the overall GroundEval framework, which begins with an event log and configuration to create a ground truth contract. This contract is then used to generate a question, which is passed to the agent under evaluation for processing. Feeding into this process, the question contract generator creates a specific task based on the ground truth. After the agent responds, the deterministic scorer evaluates the structured answer for correctness and validity, producing the final scores. Next, the framework incorporates specific evaluation tracks to test for common agent failures. These tracks, perspective, counterfactual, and silence, are fed into the question contract generator to shape the task. Finally, to make the evaluation inspectable, the agent's output is a structured answer that includes not just the answer, but also the evidence artifacts it used. This structure also captures an optional tool trace, providing fully transparent diagnostics for each question.
Up next, our 10th paper out of 10, AudioCALM, Continuous Autoregressive Language Modeling for Universal Audio Generation by Huadai Liu and Wei Xue from Hong Kong University of Science and Technology, GUST. This paper introduces a novel and promising architecture for universal audio generation that moves beyond discrete tokens to a continuous domain, potentially resolving fundamental trade-offs that have limited prior work. Let's break down its key contributions.
Let's start with the main model architecture, shown in the Continuous Autoregressive Language Modeling via Flow Matching panel. Here, a causal transformer processes text and previously generated audio, but instead of predicting discrete tokens, it generates continuous audio latents for the next block. Feeding into this, the model uses a flow matching head on top of the transformer's hidden states to predict the continuous audio. This is supported by the block causal AR flow attention pattern, which allows the model to attend causally to text and clean audio, while using bidirectional attention within the current noisy audio block being refined. Next, to handle different audio types, the model uses a unified conditioning interface. As shown by the prompt, text like "you are a music/speech/sound generation planner" is used to guide the causal transformer, treating all generation tasks as a form of instruction following. Finally, the model's architecture incorporates an asymmetric mixture of modality experts. This involves a shared FFN for all modalities, but adds a dedicated FFN speech residual path, which provides extra capacity for speech generation without slowing down other tasks. This table details the model's architecture, training parameters, and inference settings. However, it does not contain any information regarding its performance, benchmarks, or comparisons with prior work or baselines.
Those were today's top papers. Now let's zoom out. ArXiv received 1,780 new computer science papers across 79 subfields today. Here are the trending areas shaping the field. Looking at the broader trends, we see a strong push towards intelligent agents and optimizing LLMs. But foundational work like reconstructing PDE systems is also surprisingly active. Let's take a quick look at each.
Trend 1 of 10. Modeling complex learning and search. Developing computational models to understand and predict complex learning processes and search behaviors in diverse systems. This cluster covers 248 papers. Representative work includes on the identifiability of user adaptation in co-adaptive neural interfaces, the new associationism, lessons from deep learning, and estimating learner skill acquisition without temporal information. Trend 2 of 10. Building collaborative agentic systems. Developing architectures, benchmarks, and platforms for autonomous agents to collaborate and interact effectively with each other and users. This cluster covers 240 papers. Representative work includes a reproducible semantic benchmark for multi-vendor DSM to CLI translation, infrastructure for the agentic web, gap analysis and architecture from the Agentverse platform, and AONA, a comprehensive architecture and workflow design for global agentic collaboration. Trend 3 of 10. Visual AI for tracking and prediction. Leveraging visual AI to monitor dynamic changes, track entities, and forecast future events or behaviors. This cluster covers 173 papers. Representative work includes Course Blueprint, a structured pipeline for adaptive pedagogical video generation grounded in Course Corpora, a UAV-based multimodal vision system for automated side slope deformation monitoring and hazard detection, and shear-free viewport magnification for 360-degree via spherical Mobius boosts. Trend 4 of 10. Intelligent planning for robotic action. Robots leverage advanced AI, learning, and perception for adaptive, robust, and collaborative planning to execute complex actions in diverse environments. This cluster covers 151 papers. Representative work includes latent goal prediction from language from model-based planning, ArXiv, routing interactions to near-zero interference zones for continual adaptation of black box agents, and magnified, RL fine-tuning of multimodal large language models for motion planning. Trend 5 of 10. Optimizing next-gen network infrastructure. This trend explores advanced techniques and AI for optimizing the performance, efficiency, and management of future network infrastructure. This cluster covers 147 papers. Representative work includes AI Native Network Controller, a modular framework for safe agentic control of multi-domain network infrastructure, shared channel capacity, and node lifetime, an empirical study of the Lightning Network, and handling interoperability issues in 6G ORAN. Lessons learned from research lab-based integrations. Trend 6 of 10. Decoding complex signals with AI. AI-driven methods interpret diverse complex signals, from biological to environmental, for various applications. This cluster covers 193 papers. Representative work includes NeuroShield, a device-agnostic foundation model for EEG authentication, open annotations and synthetic data for field localization in Indian bank checks, and Neo-Jaundice AI, smartphone-based neonatal jaundice detection using dual-input deep learning and synthetic augmentation. Trend 7 of 10. Optimizing LLM performance and reasoning. improving large language model efficiency, reasoning, and deployment across various architectures and operational contexts. This cluster covers 255 papers. Representative work includes investigating linguistic steering, an analysis of adjectival effects across large language model architectures, exploring LLM and semantic communication for V2X networks, and human-less LLM serving, quantifying the human tax on throughput. Trend 8 of 10, formal methods and mathematical foundations. This trend applies rigorous mathematical and logical frameworks to analyze, verify, and model complex systems and concepts. This cluster covers 153 papers. Representative work includes understanding privacy by formalizing it, explicit factorization of Xn, 1 over ZP via cofactor-free single-seed Hensel lifting, and constituency optimization through Hamiltonian representation of mandates. Cothram algorithmic redistricting of Irish election boundaries. Trend 9 of 10, efficient speech and language processing. This trend focuses on developing efficient methods and architectures for speech and language processing tasks. This cluster covers 133 papers. Representative work includes less is more, lightweight prompt compression for question-answering applications on edge devices, protocol-aware tokenization and architecture co-design for wireless packet foundation models, and emo-instructed ES, dual-path instruction-guided emotional speech synthesis. Trend 10 of 10, learning to reconstruct PDE systems. This trend focuses on computational and learning methods for inferring, approximating, or reconstructing components of partial differential equation systems. This cluster covers 87 papers. Representative work includes a viscosity semigroup framework for stable image reconstruction, error analysis for a non-conforming finite element discretization of the 3D CCPF model, and ELADO, elliptic PDE assessment datasets for operator learning.
That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.